stories are good. Long
Something tells me
stories are
between the three of us, we'll fill all the time we want to fill. I'm just guessing.
I think so.
Yeah. My favorite are when we get really off topic. That's when it gets fun. Which CHAUVET page is this on?
CHAUVET Professional Facebook. Software is approved.
Go, Mike. Mike.
Hey guys, welcome to Tech Talk. My name is Mike Graham. I'm the product manager here for CHAUVET Professional. This month we've been talking about installation process and integration. Today we're going to be diving into certifications and some of what certifications are out there and what those certifications mean for you. Today I'm joined by Duke DeJean, Vice President of Sales and Integration with CCI Solutions, and Ford Sellers, the Senior Product Manager for CHAUVET Professional. So let's go ahead and jump on in. Ford, if you could take us through what some of these certifications are, like UL, CE, ETL, MET. What are some of these certifications and what do they mean to us on the manufacturer side?
Okay, well, so in the US, all of the standards are based on UL standards. And then you can have those standards tested to any NRTL, which is a nationally recognized testing lab. So for instance, we've done a lot of testing at Intertech, which is UL, and now at Met Labs, which was actually the first NRTL. They actually sued UL to get the right to be able to test things back in, I think, like the 1970s or something. So the standards are all defined by UL, and there's a bunch of different standards. So there's UL 1598, which is used for general lighting. There's UL 1573, which is stage and studio lighting. There is 6950, which is used for video wall. There's actually one that's 8750 that's actually just for testing LEDs themselves. And then, of course, outside of that, then you have all of the other things that we test to, like FCC Part 15, Subpart B. And then, of course, CE, EMC, LVD, RED, which is that except for wireless in Europe. Those are all European standards. And of course, with some products like video wall, we do TUV testing, which is testing the load ratings of different things. And then there's health standards. It goes on and on. I mean, we've got IEC 62471, which is about health, the photobiological effects of the light, and acoustical standards is actually, that's an ISO standard. But really, it's all kinds of different things that we test for, so that we can prepare stuff for folks like Duke to be able to sell into his installations.
And I just want to say thank you for doing that, because like I got lost halfway through that alphabet soup. And I'm really glad that I don't have to live in that every day.
No, it is one of the things that we try to, on our side, we try to handle a lot of this stuff so that you don't have to. Ford, okay, just out of curiosity, like for CHAUVET, when we're looking at choosing certifications, are there specific ones that we would choose for a U.S. market over a European market, over a Canadian market, or are all those tests kind of together, or how is that typically taken care of?
So that's a really good question. So typically for any manufacturer, but any reputable manufacturer, they will usually have their product and all of the standards for the flying all of the month. So basically that's for stage lighting, that's UL 1573. So, but you know, you'll just see that they'll have a mark that'll say either UL or MET or ETL or something on it. CSA, so usually that mark will just, that same mark from the lab will have a C on it. So, you know, CETL, it just means that it's covered in Canada. And then you'll see all of the CE, you'll see a CE mark, and CE covers all of the EMC, the LVD, the other stuff that the other standards that are required for the European markets. And most of those European market standards actually carry over into a lot of other international markets. So There are a few markets that require specialty testing, and so we tend to work with the distributors in those particular markets if they need a special test. Like Japan requires something called CB. So our Japanese distributor doesn't take every product. They're very selective because they don't want to pay for CB testing on every product because it's really expensive. So they're very selective about the products that they choose for their market, and then we help them get the testing done so that they can sell.
Ford, I have a question for you.
Yeah.
When you guys are looking at product and you guys are creating, do you guys, let me take it this way. Do you guys do different products for different markets because of the testing and how you get these listings are different in each country? Or do you guys try to build products that are going to really meet all the standards across the board?
Yeah, the latter. We try to build one product that meets all of the standards. And that's because we want for our product to be great, but B, also just logistically, we're a really big global company. We'd like to build one thing that we can ship anywhere. There are a few exceptions to that, things that are like voltage specific. Some products like fog machines either run at 120 or 240. You can't have you can, but it's much more difficult to have a variable power supply in those. But generally, everything else has a variable power supply that will run on 50 or 60 cycles at basically any common current. So you can plug it in anywhere around the world and it'll work. And then we have it tested to all of those standards. So again, it'll work.
So that sort of leads me to believe that the standards across the world aren't so variant that it's really hard to meet all of those kind of across the board. I mean, are they fairly similar or do they vary widely?
They don't vary widely, but they do vary somewhat. So some areas are more stringent about certain things. Some areas are less stringent. We found, for instance, going back to that CB requirement, that CB has some different requirements on the spacing of components and power supplies that are more stringent in other areas. So now as we're starting to build products that we know are going to go into CB or build products that may go into CB, we've just changed all of our standards for how the power supplies that we use or the standards that our own power supplies that we build in-house are made to, so that they meet that higher standard. So basically by doing that, you tend to take the toughest standard for each particular thing and just raise your game to meet that as the base level.
See, and as an integrator, I find that actually really cool and helpful for us as we're specifying fixtures, because we know essentially that your fixtures then are kind of tested and standardized at kind of a higher quality level. I don't have to wonder, like, did this just skirt by the US standards, but it wouldn't work other places or whatnot. Like the fact that you guys are trying to take one product line and basically make it good enough for everybody, that's somewhat comforting, for somebody like us who's got to go put these things in different places, and just knowing that it's kind of among the best of the best. That's very cool.
So that segues nicely into a question I had for you, Duke. So when you're starting the spec process and you're talking to a customer, a designer, or an architect, do you guys get into a specification discussion on, this product must be listed for this or for that, or do you just seek out products that have, that are just marked so that you know what you're buying?
Well, so the majority of the people we deal with in our normal world honestly have very little clue about any of these kinds of things. Architects certainly live deep in their world, but as far as certifications and listings for technology, like we don't even want architects generally coming up with estimates of how much technology will cost, let alone what the specs are, because they're generally that's just not their world, right?
Right.
When you get some kind of heavy hitting consultants involved, usually they'll have some sort of listings in their bid specs, and I don't know if it's because they know it or it's because they copied and pasted it out of a previous bid spec, and so it's just always in there. Um, but the reality is, from a client perspective, I can't even tell you the last time a client has asked, is this UL listed? Does it have this, does it meet this regulation? Does it meet that? They just kind of don't know. And many of them, especially when you get into government or schools, they're not even production guys anymore. We're talking to the IT managers half the time, or in a school, it's a music teacher, or it's not people who understand technology. It's not people who understand that these regulations exist. So it really kind of the onus is on us as the integrator to sort of self police, self regulate a little bit what we're willing to put in, what we're not willing to put in. On our side of life, it's important to us to put in gear that's going to be fairly low maintenance, that's going to be safe, that's going to last a good long while. We tell every client lifespan on most technology is 7 to 10 years. And so for us, if it's stuff that's we only feel confident it's going to last 3 years, we're basically either not going to do it, or we're going to raise a big flag and go, hey, this is probably a 3 to 4 year product. Are you sure you want to go here? But for us, looking at some of these kinds of certifications, safety is a big deal, especially in lighting. I mean, how many lights are up in the air, right? We can't get to them most of the time. And whether it's a school or a church or whatever, most of them don't have scissor lifts just laying around and ready to get up in the sky if something were to happen. And so, putting fixtures in that are safe, putting fixtures in that meet these kinds of testing and listings, it is important. It really is. But again, it's on us to kind of protect the clients a little bit.
So Ford, kind of going off on that a little bit more, I know that there's different standards between architectural lighting and stage lighting and outdoor lighting. What are some of the differences in those parameters, and how would those apply back into a situation like Duke finds himself in?
Well, so generally speaking, the general lighting standards are a little more stringent in terms of things like surface temperature of the fixture, because those are when you're talking about general lighting, you're talking about products that somebody could bring into their house. So that's not a product that you would have limited access to, like it's up in a catwalk. So you have some extra safety things there. Generally, when you're talking about stage and studio lighting, you also have general standards around the robustness of the fixture. Not every consumer electronic product is built to last like a stage and studio or a dedicated architectural product is. So we kind of try to build to the best of everything. And then what standard we test to is kind of, if we know that it'll pass one, we know it will pass the others because we built it to do that. So then that is really just dependent on where we think that we're going to sell it, what market is going to buy it. So architectural lights, we make like 1598, and most of our station studio stuff is 1573, or for our Canadian friends there, CSA 22, 22.2, number 166.
Okay, so going from there a little bit. When you do an installation job, obviously at some point you get the inspection team that comes in and starts looking and poking. Have you ever had instance where electrical inspectors or fire marshals maybe don't understand how the certification process work, and maybe do they question different testing standards or different markings, or are they pretty cool with pretty much anything that they see? As far as,
to be
like,
honest,
UL, MET, or whatever.
Yeah. So, in all honesty, most authorities having jurisdiction have so many things that they're looking at that it's pretty rare that we get them poking into the AVL side of life very often. You know, they're very concerned about electrical panels and electrical code. Obviously, that's something that could very easily spark fires. So they're paying a lot of attention to that. They're paying attention to things like egress and you know, ADA access and all kinds of stuff. But I mean, there's a lot of things that we pay attention to as an integrator that honestly AHJs almost never talk to us about. You know, one of the simplest ones is for ADA accessibility, you're required to have, you know, assisted listening devices, both with earbuds and with neck loops, and you're required to have a certain amount per seats. I can tell you in the 10 years I've been at CCI Solutions, I believe we've had AHJs ask us to see those, I think like 2 or 3 times in the entire 10 years I've been here. So they've got a lot on their plate, and they're very rarely going around and looking at all the light fixtures. They're very rarely going around looking at an LED wall and looking for those certifications. Again, this is another area where we have to really kind of protect our customers, and we have to protect these facilities a little bit from ignorance. Probably isn't the right word, but distraction, easily distracted authorities and people who don't know what they're looking for. And you know, when you're putting 30, 40, 50 lights up in the air, whether it's on stage pipes, whether it's on house lighting is another big one, obviously. It's just, man, it's just important that those things work, that they're safe.
Right.
You know, you get some of these cheap fixtures out there and they're using pretty thin copper for their power, and solders are bad. And I mean, it's a nightmare waiting to happen, and we just don't use them. We just don't. And we've actually walked away from some projects where people have insisted us using gear that's just not going to be safe in the long run.
So, when it comes to things like with the CE testing, we do, I know we do LVD and EMC, and then there's a new one called RED. Can you guys run us just through a little bit of the difference of that? Because I know we do have some of our people watching from Europe, so I know this is going to directly affect what they do.
Yeah, I mean, just really briefly, RED is the equivalent of including FCC testing for wireless transmitters and receivers in with the electrical testing. So that would be like taking our stage and studio standard, that's 1573, and then putting that with FCC. So they just combine it all in one thing. EMC is electromagnetic interference, and LVD is used for all of our LED stuff, or basically anything PCB with a computer board in it, and that's just their low voltage directive. So those cover all of the electrical safety plus. So in our FCC testing, we have to, there's 2 kind of clauses that you'll see if you look at the little FCC tag on anything, whether it's one of our lighting fixtures or whether it's your iron that you have at home. If it has an FCC tag on it, it's going to say this device must not cause harmful interference, and this device must accept any interference that's received. And so that is the main thrust of your basic FCC testing. That is the equivalent of the EMC stuff they do in Europe. And then if you're doing wireless transmission and wireless receiving of data, then you have to meet a higher standard. And that's the equivalent of the RED. Does that answer your question?
Yeah, absolutely. But okay, so speaking of FCC, I know this is something that we're seeing more and more. We're requested to do FCC testing. So why is that? Why is there such a focus on FCC testing right now in the world?
LEDs are little electronic things. And they tend to, as part of how they're being made, you know, they're cycling on and off incredibly quickly. That's how LEDs dim. And that creates electromagnetic waves. And so, especially now with more and more LED stuff coming on the market, you know, 10 years ago, if a product didn't have FCC, it was not really that big of a deal. But now that almost everything is LED, more and more you're having people crack down and say, hey, this needs to have FCC because the potential for interference is there. I don't know about you guys, but I have driven up to traffic lights that are LED traffic lights, stopped at a red light. I have a radio station that's just barely coming in. It's a weak radio station. The light turns green and it goes bzzz, and I lose the radio station. Thankfully, I'm driving away from the traffic light, so it doesn't really matter to me. But that is indicative of a cheap product that is not meeting FCC because it is causing harmful interference. Duke, do you ever see anything like that?
Well, it turns out wireless in the production environment is fairly important. So yes, we see this relatively often. Yeah, I mean, we kind of live on wireless these days, right? I mean, audio's been there for a while, but audio keeps getting more and more complicated as they keep repacking the spectrum. And of course, we just got a nice big repack again here this last year, and you know, our bandwidth keeps getting tighter and tighter and tighter, yet we keep wanting to throw more and more things into that limited bandwidth. So yeah, it's definitely becoming a thing. And this is where we definitely see a big difference between kind of the cheaper, less name brandy, less verifiable, less awesome products versus reputable name brand stuff that's got all these testings on it. Because I mean, we've even seen some in LED fixtures from I won't throw out names, I won't do that, but from some manufacturers who aren't really lighting manufacturers. They just basically kind of OEM a bunch of cheap junk from China, bring it in and sell it at just bottom level pricing. And you throw 40 of these lights up, and all of a sudden your RF in your room just goes completely haywire, and your wireless isn't working, and this isn't working, and what's going on? And it's RFI from your lights. I mean, it just happens when you've got stuff that isn't built well and isn't built to control that wireless kind of just blah that happens with some of these LEDs. So in LED walls, we're seeing that too. It's definitely getting better. But early on in the LED wall craze, you know, 6, 7, 8 years ago, when they were still relatively new, you were seeing the cheaper stuff at the time. It was causing all of a sudden your RF of your wireless mics on stage would just be completely bizarre, and nobody knew why. Because nobody knew yet that really this was that giant RFI wall behind you was basically wreaking havoc on your audio. So we've definitely learned a lot in the last 10 years. And
seeing more with like LED wall or with lighting fixtures or all of it, or
I've seen some of both. LED fixtures, lighting fixtures at this point. I haven't seen it as much with, again, a reputable brand name, because again, guys like you, the brands that we're putting into projects, they're getting this testing done. They're making sure that their stuff is compliant. LED walls, again, it's been a little bit Wild West. I think we're starting to settle in now to more reputable. People are learning more. But there's still some, every once in a while, we'll send out an LED wall quote, and somebody will come back and go, great, but I got this quote from this brand that's half the price. And we're going, well, we know what we buy walls for. I don't know how you're getting half the price for like product. And sure enough, as soon as they put it in, they're having all kinds of problems with their wireless. They're having problems with flickering on camera. They're having problems with refresh rates. I mean, it's basically a complete nightmare. But this RF topic is definitely a topic when you're getting non-reputable, non-tested stuff. And I think that's a point we should hit before we're done today. Because I think one thing that people don't really understand is part of the reason a CHAUVET professional fixture would be more expensive than some knockoff imported thing is because you guys are paying for this testing. It's not free. Like, you have to go through a lot of R&D and a lot of testing and a lot of dollars in order to get these things to meet these certifications. And that's part of what drives the price of the fixtures up. But if you don't pay for it now, you will pay for it later. I mean, not you might pay for it later. You will pay for it later.
Yeah, that is a good point.
So a quick segue out of that. So when we do testing, what kind of costs are we looking at on average?
Well, that it can vary greatly. UL testing can be as high as almost 10 grand a fixture. So, that can be very, very expensive. Once you start adding in things like the EMC, the FCC, all the CE stuff, the ROHS, which is hey, this can be recycled and it isn't going to kill the planet stuff. All of those other tests, you can end up spending quite a bit per fixture just on the testing. And if anything is found in testing and it requires you to change a component, that may increase the cost of your unit overall. So, it is not necessarily easy, but we're finding certainly worth it.
Yeah. But if you think about the RF side of life, especially, I mean, for me, UL, and this is too simplistic, I get it, but I'm not an engineer. So this is how I think about it. For me, the UL listing means that the copper is good, the connectors are good, it's probably not going to catch on fire. I'm happy, right?
Yeah.
The RF side's a lot more complicated though, because you can get significant RFI from power supplies, cheap power supplies. You can get it from unshielded cable, unshielded connectors. You get LED drivers that are a little bit shady. Even as simple as
how things are placed next to each other inside of the fixture that you might not have with an individual component. Yeah.
Right. No, and even the PCB boards, just having them not kind of housed well, not protected well, all those things. And then, dumb things like all of that stuff creates heat. So are there good fans? Is there good airflow in this thing too? Like, all that stuff costs money. And that's the stuff on the cheap fixtures that I'm always running away from. House lights, especially. I've seen people try to put really cheap house lights up, and I'm going, you're going to replace those in 2 years because the fan's junk, or the fan's in the back of the very back of the fixture that you're pointing down. And so all the heat's going to basically go up into the PCB board and fry the thing. Or that fan's going to get caked in dust from the ceiling or whatever. It's like, design matters, the components matter. And that's part of what I do appreciate with all these different testings and the listings that you guys and many do, is I have more faith and trust in the fact that it's probably not going to break in 2 years. It's not going to start a fire. It's not going to completely jack up the 12 channels of wireless microphones and the probably 12 channels of wireless in-ear monitors that I've got running on a stage. And if it does have any RFI to it, it's going to at least be very limited and very localized. And I can use good antenna placement, very directional antennas, to kind of navigate around it, and particularly with LED walls. So, these things for me are very important. This is the practicality of really all the work that you guys do. This is the practicality of what it means to us in the production world of making a stage functional and not having audio fighting video, fighting lighting, because they're all basically emitting stuff that just doesn't like each other.
So along those lines, so when it comes to some products that we do, we don't do MET on everything that we do. So when we ship products to someplace like Canada and they have to do site surveys, what kind of process is that like, Ford?
Well, Andre is on right now. I see him there in the chat.
Yeah, he's lurking.
He is. So most of our professional gear is tested to the. In fact, I'm straining to think of anything recently that hasn't been. It's tested to the CSA 22.2 number 166, the Canadian standard. Not all of our DJ gear is, and that is both because the application is different, and the value proposition is different. So the higher end products certainly are, because those may cross into more professional applications. But some of the other products, the more consumer grade products, are not. And what happens is that those are imported into our Canadian distributor. And then they have somebody from the lab come out and do basically on-site testing, and those are stickered there as CSA compliant. And that does kind of two things. First of all, it makes it so that our Canadian distributor can sell them in Canada, which is really important. And then secondly, that also means that it sort of acts as a protector for our Canadian distributor, because that will prevent somebody from buying that similar product on eBay or Amazon and having it shipped from Detroit, because the one that shipped from Detroit doesn't have the CSA. So it's kind of a two-sided thing, but we pretty much always try to build our products to those standards, so that we know that when it goes to Canada, it's going to be fine. Every now and then we get a weird red herring where something in Canada is just different. The rules are different. It's not necessarily a tougher standard. It's just a different rule. And then we have to change some component or something. And usually when we do that, we'll just change it throughout the entire production line. We won't say these are the Canada only products that we're going to change this in.
So speaking of that, do we ever find rules that are contradictory? Like it's this way in one place and then completely different someplace else? Or are they usually pretty complementary, where you just pile on and on and on? Right now, so we lost power for a minute.
How is that possible? It's not 3 o'clock there yet. I thought those storms were only allowed between 3 and 5.
It's a funny story where our building is. We're kind of at the end of we're right before the Everglades, so we're at the end of the line. So we lose it out here every so often this time of year. So it is nice. It's all good. Luckily, everything has surge protectors, so it never causes problems.
I know Infocom. I just plan on somewhere between 3 to 5 every day. It is just going to downpour for like 45 minutes.
Yeah, so it's that time of year. So, alrighty. So back on topic. I believe that we left off talking about
something about Canadian standards or
Canadians. Yes, we're talking about Canada.
Match. So yeah, I mean, for the most part, yes, they all match. The story I was telling was that basically CSA was updating their standards to come in line with all of the updated UL standards. And then there were a few things that were like silly standards that we were able to look at and say, these things no longer really apply. Things like putting a wire mesh over the front of your glass lens is no longer as important as it may have been when you had 2,500 watt HMI lamps.
So that's kind of actually that kind of raises an interesting question. When I don't know if we have the answer to this right off the top of our heads, but like when a standard becomes obsolete, do they just rewrite the standard, or do they have to go back and rethink things, or how does that typically happen?
They update standards periodically, and when that happens, if you have a product that met the old standard, there's usually a overlap time. So they'll say, here's the new standard. It's published in April of 2020. It will take effect on all products in December of 2021. And so basically you either update your testing to meet those new standards, or you retire your product. So oftentimes we do have to have products retested to meet the new standards.
Yeah.
Which kind of leads me to sorry, I just had a quick question for Duke along those same lines. I know that a couple of years ago, the FCC changed the bandwidth allowance for microphones, for example. When that happens, how does that affect you, and what do you guys do about it?
Well, it throws everybody into a tailspin for sure. We had this with the 700 megahertz repack. Gosh, what was that? 5 years ago, something like that. And then the 600 megahertz last year into this year. And it really just kind of throws everybody for a loop because you get the manufacturers who now have to really get new product and new frequency ranges out there. Sometimes they already have it, but sometimes, I mean, it always certainly impacts what their product offering is. Um, but it also throws a lot of confusion out there, especially after two repacks in a short amount of time. Everybody's going, well, gee, what do I get that's going to be future proof? And if only we could figure out what the government was going to do, next year, let alone 5 years from now, right?
Right.
So knowing what frequencies are still going to be available a couple years from now, knowing what our options are going to be down the road, it's tough. I mean, and you guys know this because you're dealing with it too, but it just puts you in a really, really tough spot for any kind of future planning, any kind of trying to buy something that's really going to last you 5 to 10 years. On top of the fact that now I've got to shell out a ton of money to basically get rid of, like, so for in our world, churches in particular, a lot of churches a number of years ago had jettisoned all their 700 megahertz stuff out and had to replace it. And popular equipment at the time was 500 into the 600 megahertz bandwidth range. And so now all of a sudden, if you were one of the people that bought a whole bunch of 600 megahertz stuff, you're replacing all of your wireless mics for the second time in less than a decade. And not because it didn't work, but because the government decided to repack all that frequency. So it's a big deal. And wireless in particular is complex enough that the uncertainty of what'll happen next and what's the government going to do to us next time is tough. And so I think that's part of where it actually puts more importance on just kind of the future of testing on product with RFI. As our bandwidth gets more and more limited, it becomes that much more critical that the other products, the non-wireless products we've got in our production venues, aren't creating a whole bunch of wireless interference.
So, if you had to pick something that you pay attention to super closely, I guess the wireless interference and RF issue is probably a pretty big one for your neck of the woods.
It is. Yeah, wireless is one of those things. Everybody wants a clean stage. Everybody wants flexibility. And you've got obviously wireless connectivity for networking. We're seeing more and more wireless connectivity even in the lighting world. Some in the video world, it's still a little price prohibitive to be normal and commonplace there, but it's getting better and it's getting more cost effective. But yeah, I mean, it's one of those things where, especially in the audio world, we've got to have great antenna placement. We've got to have the right antennas. A lot of people think just kind of instinctively, if some RF power on my wireless mics is good, all the RF power in my wireless mics is better. And so they'll just crank all of their wireless stuff all the way up to full power, not realizing that actually will probably make it worse. You're actually better off having them kind of lower power with better antenna placement and very directional antenna placement, because then you're not getting a lot more crosstalk and you're not getting a lot more kind of things fighting with each other. So I think those kinds of things definitely are hot topic for us. And especially as we see more LED walls, and especially if we get into venues with a lot of cheap LED type of product, fighting RF is definitely a common topic. And there's so many things to look at. Again, some of them are just as stupid as just, even though the pack is capable of doing however milliamps, maybe we don't need to turn it all the way up, turn it down and just put an antenna in the middle of the stage, kind of a thing. Sometimes it's simple answers, but sometimes it's, hey, we just invested, $50,000-$60,000 in this LED wall. And ever since we put it in, our wireless has gone completely haywire. Yeah. Well, where's all your wireless? Well, it's backstage behind the LED wall. There we go. Let's let's maybe work on some different antenna placement, and let's run all the antennas out to get some really strategic directional antennas, put them out to the side of the stage, where they're avoiding being behind the LED wall. So this stuff all plays together, and it's important. It's important to have good equipment that takes these kinds of testing, this kind of how it interacts with other stuff seriously, and kind of values where it fits and how it has to fit in the world of production.
Cool. So Ford, if I wanted to educate myself more on what goes into all these NRTL testings, or CE testings, are there websites I can go to kind of get to expand my knowledge to understand these listings and how they do it?
I have never really found one. The way that you can go and you can see the brief and the scope of the different standards, the different UL standards, if you go to the UL webpage. And so it'll tell you, it gives like the brief introduction of what it is and what it covers and kind of why. But the standards themselves are actually incredibly expensive to purchase a copy of. It's not like the ESTA standards. So for instance, all of our ESTA standards, you can go to the ESTA website and there's, gosh, it's an insurance company. I don't remember the name of it, but they basically paid the fee for anyone to be able to see all of these standards for free. So you can just go and download them and you can read them. And the ESTA standards are they're more like practice standards. So, there's standards on how to measure light. There's standards on all of those sorts of things. But the actual electrical safety standards and the FCC standards, all of those are standards that you actually have to purchase in order to be able to read in full. It's like the NPFA fire standards, same sort of thing.
Right. Okay.
If you try to read them, they are just like, if you think that my spouting alphabet soup is boring, try to read it. If you have insomnia, I highly recommend trying to read a technical standard. It'll put you right out.
So Ford, I have a question.
No doubt.
Out of curiosity from my side, like how much have these standards really changed in the last 10 years as more conventional lighting kind of continues to fade away, and even some areas, I know Europe, what was it, 2 years ago, almost tried to completely ban it altogether. But as we move more and more towards LED, like how much are these standards changing really, or is it just kind of just small incremental things?
So you've seen more changes in the last 10 years than you had seen in probably the last 25 before then. At least, especially in lighting, specifically because in the last 10 years, people went from talking about LED lighting to using some LED lighting to virtually everything becoming LED. And so you've gone from incandescent to electronic wholesale. So there's been a huge shift in the technologies that are used in the industry, and that has driven the updating of the standards to make sure that they can actually meet those standards. That they actually produce more RF, because it's not just a little bit that's in your space anymore. Now it's a ton.
Yeah.
So to just kind of because we're nearing the end of our time, just want to throw out there and say, thank you to both Ford and Duke before we do run out of time. But if you guys have anything that you wanted to just kind of throw out there before we close out, that'd be awesome.
While we're looking for that, Ford, this is a little off topic, but I think connected. What are you seeing? What are you guys hearing as far as like I mentioned, Europe was really pushing to get rid of incandescent here a couple of years ago. I'm kind of waiting for the day where incandescent stage lighting and house lighting in particular just basically are not allowed anymore. What are you guys seeing? What are you guys hearing? Or in your magic 8 ball, what are you guys predicting?
Yeah, the crystal ball is not exactly super clear on that, but more and more, yes. The European standards getting rid of incandescent lighting, they're there, and there's they pushed back some of the implementation, but overall it's being implemented, and it's not going backwards. You're seeing that in other countries around the world too. That's just how things are going. We don't use an incandescent lamp, I think, in anything that we currently manufacture anymore. Everything has gone to some alternative light source. Almost all of it is LED. There's a little bit of arc source, and we've been looking at some other technologies, but primarily it's LED. And I think if you go to Home Depot or I don't know what the equivalent is in some of our other countries, but the home store where the hardware store, it's really difficult to find any sort of lamp there is still compact fluorescent, and there is LED, and outside of those two, you're not seeing much. That's just what there is now.
Yeah.
So it doesn't even take a crystal ball anymore to really see that incandescent is toast.
What I'm curious, what do you see as the future of arc lamps? I mean, I know those were in every moving light for years and years. We're starting to see a lot of things move away from that, but not everything.
Well, the one thing that technology still does well is beam style fixtures, because they use the ultra short arc with the built-in reflector. So that's the new Ushio lamps, that's the Osram Sirius lamps, that's the R series from Philips. That allows a super high concentration of lumens to spew out the front, but it's not really very, very controllable. So it's good for a beam, it's less good for a spot, and it's less good for a wash. An LED is a much better, much more efficient light source for a wash than those arc sources are. I think that what you're seeing is every major manufacturer is moving towards higher power, and by higher power, sometimes it's higher electrical power, sometimes it's more efficiency with the LEDs, but basically LED source lamps in their spots and in their washes. And I think it's a matter of time before you see it in beams too. The technology is just continuing to get better.
Yeah, cool.
As the lumens per watt keep on increasing, and the compactness of the source becomes smaller, doing beam and hybrid fixtures becomes more advantageous in that source. And I know it's the goal, because going back to carbon arc is just not an option at this point. So, hey, carbon arc is awesome. So, yeah, I just think that as things evolve, I mean, think about how far we've come with LED technology just in the past 15 years, for example. We started out building, effect fixtures and some 36 watt par cans with RGB LEDs, and now we're building these massive spot and profile fixtures that look absolutely fantastic. And I can't wait to see where we go with this in the next couple of years, to see some beam and hybrid fixtures come out in LED and be really good, and it's going to be awesome.
Here's a question, Duke. What was the first LED like wash light fixture that you ever purchased?
I was actually I almost was gonna throw this out. Back in 2005, I think it was, we did a remodel. At the time, I was a tech director at a church in Cedar Rapids, Iowa, and we bought, I think it was somewhere like 30 of the Elation Design 36s. little pot of gold thing, right? I mean, it does literally looks like
Yeah.
a pot with 36 LEDs in it. And it kills me because I actually was just back up there a couple of weeks ago, and they're still using like half of them. So there's these 14, 15-year-old design 36s, and none of them match colors. They haven't like since year 3. Um, like you put in Zephyr Blue was one of my favorite colors because it was just kind of this bluish purplish. It just was a really great color to use for lighting the backdrop, especially during message times, because it was just kind of such a cooling, calming color. But by year 3 or 4, I put Zephyr Blue into the console, and I'd get like 4 different versions of it, right? And I mean that, like all of the original LED fixtures were almost that way. You know, it was all experimental back then. But it's so funny because I look at, like, you guys have, I think, probably 4 or 5 different fixtures right now in the DJ line. Those things were like $1,000 a piece at the time. You guys have like 4 or 5 fixtures in the DJ line that have more output, more color consistency, better longevity, and they're all like $300 a piece now.
Well, yeah, now, yeah. I mean, it's
So
like,
it's
no,
just it's
crazily
but
progressed.
it's so crazy just to see how far things have come in 15 years. Because I mean, I remember when 15 years seemed like forever. Now it feels like nothing. But I mean, just how far LED has come. I mean, now we've got extremely high power moving lights that are running on 300 watts of
Yeah.
LED,
Yeah.
where, those things needed a 15, 20 amp breaker a piece back in the day. So I'm excited about where we are right now. Some amazing house lighting fixtures that are doing full color with amazing color rendering, and they're all 150 watts a piece and plenty bright. Um, Ellipsoidals. What you guys have done with the Ovation line, I think, really has set a bar for ellipsoidal and Fresnel fixtures. We use quite a bit, especially the Fresnel fixtures this year, with churches in particular having to move to just streaming. Our audience is only online, and we've got to have good video lighting. I mean, a handful of the Fresnel fixtures you guys have make amazing video lighting. And those things are going to be fantastic. They're going to last forever, and it's just really simple to get a good even wash out of them. And I swore off Fresnels years ago because in a live music environment, my Fresnel lamps would always just burn out because you get 100 decibels of audio going with good low end, and those things are hot. They're gone. Yeah, they're gone. You blow bulbs left and right. So I swore off Fresnels years ago, but what you guys have done with your Fresnel series in particular has made me fall in love with Fresnels again, especially for video venues. So I love where we're at in LEDs. It's exciting to think that it's only going to continue to get better. But yeah, if you think back to all my little pots of design 36s and the things that are available to us today at half the price or less, it's exciting.
My first LED fixture that I ever got, I was working, it was again about 15, 16 years ago. And I was working at Cornell University, and I wanted to get something to experiment with LED because here's this new technology that's coming. And so I actually got some Color Splash Junior lights from CHAUVET before I knew who CHAUVET was. And we put them in our light lab, and it was, I look back at that fixture and I think, wow, at the time I was like, wow, look at this really cool thing. I can't believe this actually puts out light with LEDs. And now 1,000 light years ahead of that.
And we're using LED tape. I mean, not the cheap stuff you get on Amazon, because again, that comes with all kinds of problems. I saw one note in the chat that said, yeah, you get too close to LED tape with a walkie-talkie and you change the colors. We're not talking, I don't use that stuff, like the good professional tested stuff. But I mean, we're using LED tape more and more just as architectural highlight lighting, and those kinds of things, because we're finally at a point where it's quality, it's consistent, it's not creating a whole bunch of RF in the room, and it actually works all the time and not just some of the time. You know, that's an important one for us. It has to work all the time, not just sometimes. But I mean, you know, some of what I can get in LED tape now blows away what I bought 15 years ago.
Mhm.
So actually, that is a perfect segue into what we're going to be talking about in our next Tech Talk. So tune in, I believe, next week for our next Tech Talk. We're going to be talking a lot more about installation and how to choose fixtures for your installations, or how that's kind of done. So please make sure to check us out next week, same bat time, same bat channel. I'd like to thank Ford Sellers and Duke DeJean for joining us today. We'll be hanging out in the chat for a few more minutes when this is over. So if you have any additional questions, just go ahead and throw them on in there. But guys, thank you so much for hanging out today and enduring our small technical issue. And we'll see you soon.
Thanks, everybody.